You've heard the hype about Prusa Slicer, so today we're going to go in depth all the way from installation to print. Let's get started. Hey guys, Bryan here with TheFirstLayer, the show that explores the world of 3D printing. Continuing on our series of slicers is Prusa Slicer. Now there's been a lot of hype around this, especially with the newer release of 2.3, and we're going to go into some of those features here. But what is Prusa Slicer? Well, Prusa Slicer is a fork of the popular slicer Slick 3R or Slicer, or however you want to pronounce it. But basically it was designed and optimized for the Prusa line of printers, and as it's grown, some of the feature sets have been so desirable that users have asked for it to cover more third-party printers. So now, especially now that we're at version 2.3, there's a lot more focus on adding third-party printers and easy set features for your machine if you don't own one of his machines. So let's go ahead and start installing it. Okay, so first things first, we need to download Prusa Slicer from Prusa's website, and you can find that at www.prusa3d.com/PrusaSlicer. Now on the website here, you can see we do have downloads for Windows, Mac, and Linux. So we're going to go ahead and get the standalone installer. This is the new installer that removes some of the extra components, since we'll just be using the slicing components. But if you do want to use all the other drivers and apps, you can go ahead and download this full installer. So we're going to go ahead and click the standalone installer, and we're going to run it. Okay, now we've got the Prusa Slicer installer up, and it's going to say welcome to the wizard. We'll click next. And make sure you install for everybody. I don't generally do the only for me anymore, just in case if a user account gets corrupted. So unless there's a security reason, you'll want to install it as everybody. If you need to change your drive location, you can change it here. Obviously, we have enough room on our C drive, so we're going to go ahead and install in the default location. And we'll take a look at the list of all the options here. Now you can see by default it's installing the 64-bit version of the application. Now it's got drivers in here for firmware. If you don't have any Prusa printers, we can go ahead and unclick all that just by clicking on this top box here. Now there are some sample objects in there, but we'll probably have enough standard objects already on our computer, so we'll leave those unchecked. Common files are required, and you'll see down here under utilities, it actually installs some extra utilities here. Now by default it just gives links, so if we uncheck that, we can go ahead and add in an interface for Pronterface and for NetFab. And we'll get into these a little more in a future video. It's a good idea to have them installed for now, but you can leave them unchecked if hard drive storage is an issue. Now, as we mentioned above, it still keeps the installation location, and we will go ahead and click Next. Create your shortcuts as necessary, and let the install run its way. Once we're complete, hit Finish, and Prusa Slicer is installed. So we can go ahead and close our browser window, and we'll have a shortcut for it on our desktop. Now on first launch of the application, it provides us with this nice configuration wizard. So let's step through this step by step. First, we're going to go click Next to jump to our next step. And it asks us which printers we want to add in. Now you're going to see by default, it's showing us a bunch of Prusa printers. If you don't have one of these though, we're going to go to the left-hand side here, and you can see they've got profiles for SLA printers and other vendors. Now this is where my recommendation is to stick with something that works. Regardless of whatever printer you have out there, I recommend we start off with the Creality FFF profile, and if you want, we can select an Ender 3 with a 0.4 nozzle, or we can go for something like an Ender 5 or a CR10. Change it around based off the size of your build plate. Now in my case, I've got a CR10, so even though it's a little modified, it's still a CR10 with a 0.4 nozzle. So let's go ahead and start with the CR10 profile. And you can see they've got different ones for S, S4. These should mostly be the same, but actually for accuracy, let's do the CR10S profile as well. Now you can select multiple printers throughout here, so just make sure whatever you're adding, you go through and uncheck the other ones. So we don't need the Prusa Mini, we don't need the SLA, just make sure they're unchecked, because otherwise we'll have a bunch of profiles after the fact. So we can see we just have the CR10S profile selected. Next, we'll go to the next tab here, and we can define a custom printer profile. We won't actually be defining that because we created one based off the Crealities, and I'll show you later on why we used the Creality one as the reference. Next, we'll move on to filaments. Now, there is all sorts of flexibility for different profiles for what you can set up. What I usually like to start off with is Creality PLA, and actually, in fact, what I like to start off with is generic PLA, generic PETG, generic ABS. If your machine can't print ABS or you're never going to, just get rid of that one for now. But we'll leave a generic PETG and PLA. Now you'll see there are compatibility profiles for different machines. So if you buy a very specific filament, for instance a Prusa, or you buy DOS filament or extruder PLA, they've generated these pre-created profiles that's best suited for that material type. Now most of us are probably using cheap Amazon filament or various brands such as Matter 3D or filaments.ca. And if you're using that, we're probably going to want to start off with these generic profiles and we'll customize them for our filament as time goes on. So if we're all good with the two profiles here, we're going to click on Next. Now this is a really nice feature, the update built-in presets automatically here. Now Prusa is always updating profiles and they don't always warrant an upgraded version of the program. So it will prompt you and say, hey, there is an update to the printer profile, such as a tweak from a user that they've incorporated into the standard profile. And this will make sure that you have the ability to pull those updates automatically, and it will prompt you and ask you what options you want to change. And the key item here is updates are never applied without user's consent and never overwrite user's customized settings. And we'll show you what a user customized setting looks like shortly here. Now click Next. I personally have never set this setting, however, we'll just leave it unchecked for now. File association. So if you do want double-clicking on STLs to open into Prusa Slicer, you can do that. Same with 3MF. This is generally better if you only have one slicer on your computer. So just to ignore the confusion for now, we're just going to leave those both unchecked. Finally, we have the view mode. Now this mode here is where we're going to start out with, is in the simple mode. And you'll see there's a button that allows you to switch between simple, advanced, and expert, and it just exposes more settings to the end user. So we're going to start off with our simple mode and see what results we can get, and then we'll dive further into the advanced and experts to show the changes that you can make that aren't exposed in the simple mode. Now, if you are a user that primarily works in imperial units, you can select this to use inches. By default, this program works in metric, and so if you import a model that it thinks might have been an imperial baseline, it will actually give you the option of rescaling up to the metric size, which is a 2,540% increase. But if you primarily work in imperial units, including when you're working on your machine, you can select use inches, but I have never used that setting. Now with the baseline set, we're going to go ahead and press Finish, and we'll have a default build plate. Now this is actually designed to look a little bit like a Creality V2 build plate, and that's some of the customized features you can do when you build a custom profile. But for us, it's fine. Okay, here's our main landing screen. Now this is where we're going to be placing models and adjusting their positions and doing any of our base modifiers. Now you'll see at the top, we only have two options that aren't grayed out currently, which is Add, which will add our STL file to the screen so we can place it, and this other one here. Now this search actually gives you all of the different command features in case you're unsure of where they hide in the slicer. And I've never actually used this until now, but it does give you a nice quick ability to find a feature. So if you're ever unsure where something is located within Prusa Slicer, this gives you a quick click, so you go and type in something such as support, and it's going to show you for options for material, generate supports, and auto-generate supports. So this is a great feature if you're not sure where to find something. Now going back to our interface here, you can also see we have some information to the right. And this is where Prusa Slicer is a lot closer in design to a program such as Simplify 3D. Namely, you have a print setting, a filament setting, and a printer setting. And where this is neat is you can build profiles, and you'll see they've built profiles for anything from 0.08 all the way up to 0.28. And if you ever decide to switch between two machines, you can go to Printers, and you'll see your list of printers. Now we can see we've got this one locked here, System Presets. But if you click on here, Add Remove Printers, we can add another new physical printer. And this gives you options for connecting to printer paths and so forth. If we want to add an actual new machine, we'll go through that shortly. Now under the simple view, we have the ability to select supports, support on build plate only, for support enforcers only, and everywhere. So generally, most people will select everywhere or build plate only, and we'll take a look at the support enforcers shortly. Our infill ratio is our standard percentage ratio of infill, and brim gives the ability to add a brim to your model. So let's go ahead and add our file to the build plate. All right, we got our build plate set up here. Let's go ahead and add our file. To add our file to the build plate, we're going to go up and press the plus button here. And we're going to go ahead and we've downloaded the 3D Benchy already. So let's go ahead and place this on our build plate. The exclamation point indicates there are errors on the object. Now it will attempt to do an auto repair, and if it's not fully successful or if it gives you additional options, you can see there's the option to right button click the icon to fix the STL through NetFab. And that's why we install NetFab with this, is this gives us the ability. But we're not going to cover NetFab today. We're going to assume that the model is good to print. Now under this field, you can see we have position, X, Y, Z, rotation factors, scale factors, and the actual measurable size of the object. So to simply put, if we want to scale this boat up to 200%, we can go ahead and type in 200, and it will copy it across to all three parameters. You can do individual axis scaling, but generally you want to keep the same proportions. So let's go ahead and set this back to 100%, and we'll have it sitting in the middle of the bed. Now on the left-hand side, we also have the same controls to move around, to scale, to rotate, and to place on face. Now this feature is one I've been using more and more lately, and we'll show you how it works here. So let's say if your Benchy came into your computer and it was positioned at a weird angle. Let's go ahead and rotate this guy, and let's go ahead and rotate it and place it on an angle such as this. Now let's say for some weird reason you want to go ahead and you want to place it so that the back part of the boat here is flat on your build plate. So to use this feature, we click on the Place on Face feature. And what I like about the visualization here is it gives you blobs that indicate the angle and the face that would face flat down. So if we rotate around our view here, we can see the bottom of the boat is an option, the back of the boat is an option, but based off these different circles, these are all at different heights, so it's not recommended. Now let's say we do want to still place it down on this face or as close as possible. So we'll just go ahead and click on that face, and you'll see instantaneously it's rotated to have that face as flat on the build plate as possible. Now if we've done some movement and we really have mucked it up and we want to go and place it back down on the bed, we simply use this tool again, go to the bottom of the boat, and click on it. And it will position itself flat to the build surface. This is great when a modeler doesn't put the bottom of the model completely flat on the build plate. Okay, so now that we've oriented the model how we would like it to be for printing, let's go ahead and look at the various settings we have here. So now our supports we have set to none, infill 20%, and let's go ahead and put a brim on here just to have it. Now you'll notice at the top, your profile has now changed to have the brackets words of modified. Now, if you do change settings and you do like them, you can go ahead and save those settings. For now, we're going to leave it as modified so that if we do have any problems, we can roll it right back to the 0.16 optimal preset. Okay, so if we were happy with all of these settings out of the box, we can go ahead and just hit Slice Now. And you'll see it goes ahead and starts generating G-code, and it's extremely fast. Now, the reason we're looking at this screen before we look at the rest of the settings is there's an amazing little chart in the upper left here. Now what this does, this actually breaks down each part of your 3D print, what kind of feature it is, and how long it takes. So if you're looking at optimizing your print and you have a feature that takes a large amount of time, you can look at trimming back the settings for that particular feature. So what we can see here is based off its estimates, it's going to take 29 minutes to print the outside walls, 39 minutes to print the outside perimeters, 15 minutes for the internal infill, 33 minutes for the solid infill, and then a little dribbling amounts for things like the gap fills and the skirts there. So there's not much to optimize here. However, let's say if our infill here at 33 minutes, let's say we wanted that to take a little bit less time. Now 20% is a high infill number. Depending on the parts that you print, you may want to have more infill, you may want to have less. But for the Benchy, usually we can go safe with a 10% infill. Now where Prusa Slicer is powerful is that it only regenerates the features that have changed. And in this case, it's just going to be the infill. So when we hit slice, it's going to go ahead and actually generate it at a much faster rate because it already generated all the other walls and we haven't changed those settings. It just goes and recalculates your infill. Now we can see with 10% infill, we're still looking at about 33 minutes. Now your bars at the top and your bars at the bottom, these allow you to slide and look layer to layer. So if we want to go down and see what it looks like on the inside walls here, it'll go ahead and break that down layer to layer. And then the bottom slider allows you to see the individual draws for that particular layer. So in this case, we can see that the lines of G-code 34,213 to 31,129 are related to the height of 9.64, which is about layer 60. So if we slide this back, we can actually go and see it drawing all the features of that layer. This is sometimes nice just to see the order of how it optimizes the drawing features and see if you're doing a lot of weird things like hops. Now once we've done this with this layer, if we pull it back a few points and we zoom in, now we can have a better view of the colors and the features, and that's what these colors correspond to over here. So we can see this darker red is internal infill, which is indicated from the front of the boat here. The yellow line is the perimeters, and the orange line is the outside wall. Now we'll talk a little bit more about the perimeters shortly here, but in general when you're printing, you want to go slowest on those outside layers for the detail, and you can go a little faster on the inside as it doesn't usually show on the outside. Okay, now that we've gone through our boat slicing here, you'll see there's two buttons in the bottom left here. There is a layer view and a solid view. So the layer view will show you whatever the slicer has calculated so far for the G-code if we were to export. And you can also tell when we're in this mode we have the export G-code button on the right hand side. Now if we want to go back and rearrange our models, we're going to have to go and click on the cube over here, which changes us back to our previous modeling view. Now until we make a change, it hasn't erased that data, so you can still go back and go ahead and export the G-code. You don't need to regenerate it. Now that we've broken down the basics of slicing, let's go through each of the tabs and see the features we have to play with at a more detailed level here. Let's start off with print settings. Now under print settings, you can see at the top we've selected this 0.16mm optimal at creality, and it notes modified because we did modify by adding a brim. Now under these views, you're going to see there's a simple button, advanced, and expert in the upper right. Now as you click on these buttons, it reveals more and more features, and one cool feature is that if you enable expert, you can actually go down and see the dots that correspond to what feature level or what configuration level is exposed to the end user based off the selection up here. Now under expert mode here, you can see for green ones we have layer height, first layer height, perimeters, spiral vase, and seam position. If we were to go back to simple, that's all we're going to see that's exposed to the end user. The horizontal shells are always visible by default. The horizontal shells are shown regardless of mode here. Now, if we did want to add any extra features and we couldn't find on this list, then we can go into Advanced and Expert to expose these. However, if there are too many settings and you want to keep a simple view, go ahead right back to Simple. For now, we're just going to use the Simple feature set. Now, under the layer height options here, we have our layer height, which is set to 0.16, and you'll see the first layer height is set to 0.2. In a previous Tuesday tip, I talked about raising the first layer height to give it more bed adhesion if you're having troubles with bed adhesion. Now with a 0.4 nozzle, you can safely go up to about 0.28 for your first layer, and then keep it at 0.16 afterwards, and I find this helps with bed adhesion, and we'll see that happen on the print. For vertical shells, our perimeters is just the number of outer walls. Now by default, it starts off with 2, but we can change that to 3 or higher if we need a stronger outside wall. Let's leave it at 2 for now. The other setting available to us is Spiral Vase, and this allows us to do vase mode, where we print an individual wall and have the nozzle slowly raise as it draws around the outside. There are some cool model files on Thingiverse that allow you to print these single walls, and we've featured a couple of them on our Facebook group. But for today's example, because the Benchy has multiple external walls, simply put, Spiral Vase would not work for this example. So we're going to leave that unchecked, and for the majority of prints, you will not be using this setting. Finally, under Advanced, we have Seam Position. Now, Seam Position is your Z seam, and Prusa Slicer gives you several options about where you want your seams to occur. You can have it as random if you don't want a rigid seam line. Nearest keeps it nearby. Aligned is a straight line up the model, and Rear attempts to put it at the back of the model. Now, in most cases, random is a good one. I personally like to have it aligned because then I have a single sanding position up my model there. But it all depends on your retraction settings too. If you're having a bunch of blobbing at the end of your lines, aligned makes it a lot easier to remove that with sanding after the print. So let's stick with aligned for now. Now you'll also notice a bunch of items since I've changed here have changed to orange. We have layers and perimeters, infill, and skirt and brim. This is showing settings that we have changed since we went and loaded up the 0.16 optimal profile and have not hit the save. If we do save current print settings, it's going to go ahead and commit those into that profile. So if we hit save, you can either overwrite other profiles. In this case, because it's locked, you're always going to have a go by baseline. So today we're going to call this 0.16 millimeter first layer. Now this will update to the top to say first layer, and you'll see it's under user presets now. Anything with a lock is a base profile that you can't go and overwrite the baseline, but you can derive a new user preset from one of these. So now if we go ahead and change the 2 parameters to 3, it's going to go and tell us we have changes again. And if we hit save, it's now going to give us the option to overwrite our first layer one or create an additional profile. So we'll call this one first layer 3 walls. Now if you end up having too many items on this list at any point, you can click on the profile in question and click delete this preset. It's going to make sure you are okay with deleting the preset, and it'll be gone from your system. Now we'll go ahead and load up the user preset we were just building before, and let's continue on. The next section we're going to have a look at is infill. Now infill, again, if you go to expert mode, there's a lot more settings exposed, but we're going to keep to the simple mode for now. Our fill density is our infill rate that we set over on the plater screen here, and we can see it's 10% and it carried over as 10%. The fill pattern gives you many different fill patterns, and we won't go through the details of all of them today. However, my favorite one is adaptive cubic. This one is similar to the gradual infill of Cura. However, it goes and builds a much stronger interface, and it basically adds more infill as it gets closer to top layers. It's kind of a hybrid dynamic infill, and you'll find it'll make your prints stronger without using any more print time. So let's go ahead and overwrite our default. Now the 2 items below it, monotonic, are a new feature in Prusa Slicer 2.3.0. And if we look at this infographic, it's a different way of handling how it paints the top layers. And you may have not realized you had an issue until you see their before and after photos. And it has to do with how it draws its diagonal lines. So we're going to go ahead and leave these at monotonic. This is the best way of doing it. However, you can still do items like concentric, chords, spiral. I personally haven't played with them. I prefer to stick with monotonic because I've had the best results. The next tab we're going to have a look at here is the skirt and brim tab. Now this defines the parameters for your skirt and for a brim. Again, if we look at expert, we have abilities to change items such as the loops minimum, which is the number of skirts around the outside, and we have the ability of setting our brim width. The brim width defines the thickness of the brim from your model moving outwards. So at 5 millimeters, if we go ahead and slice our model, we're going to have 5 millimeters outwards filled with perimeter lines around the outside. And this is great for helping with bed adhesion if you have tiny details that simply won't bind to the bed well. So we're going to go ahead and leave these settings as is. However, it does give you a lot of options to go and add additional features for our loops here. To enable paint on supports, we need to move up from the simple mode to the advanced mode. So in the upper right, we're going to go ahead and click on advanced. Now you're going to see some new features pop up on your left-hand side. We have paint on supports, and we have seam painting. Now when we talked about our Z seam earlier, we told it to align to a singular point. However, you can actually paint on a point and tell it this is where I want the Z seam to exist for these layers. So what we're going to do just for fun is we're going to go ahead and paint and say we want our Z seam. That's actually probably a terrible place. Let's go right up the bow of the boat. That way if we need to sand it, it'll be a nice easy point to sand. So it provides you with a brush, a round brush, and you can adjust the brush size to a sphere, circle. I haven't used clipping of view myself, but we're going to go ahead and we're going to paint a line straight up the front of the boat. So now when it slices the file, it's going to try and position the Z seam within where I painted on here. Now the same will apply with paint on supports. All we have to do is paint a line where we want it to generate supports. So let's say we want to paint it up the front of the boat. We're going to delete this obviously when we print because this benchy does not require it, but for this example, it's a great way of showing it. Now let's say that this window in particular has been giving us problems. The archways have been okay, but the window has been giving us trouble. We'll click once here, and it'll add a blue block there as well. Now we've got a line that says generate supports along the front of the boat and along this window. And if we go ahead and hit slice, you can see it's now generated supports where we painted on and nowhere else. And the same goes for the back of the boat. So this is a very powerful feature that we will be covering in depth in a later date, but just to get started, that's how we do it. So as we don't need these supports, let's go ahead and go back to our print settings and turn off generate support material here. The good thing is this will save our painted mesh in there if we do choose to add those supports later on. Now the overhangs threshold is locked down, but you can override this. This is the angle at which it chooses to do supports. So we've gone ahead and turned off generate support material and auto generate supports. As well, for supports we have the option of going up from the build plate only. So if we have an overhang that is within the model, it won't print a support for it, but if there's a direct path downwards to the build plate, it will add supports. Okay, we've got our base print settings set, so let's go ahead and save that profile, update our settings, and we'll see everything has gone away from the orange color, meaning we have no unsaved changes. Let's move on to the filament settings. Now the filament settings tab, you can see has changed at the top to this generic PLA at Creality. And if we click this drop down, these were the two profiles we created earlier, generic PLA and generic PETG. So let's go through with our filament. Our diameter is 1.75 millimeters. Our density, which just helps for calculating the amount of filament it uses, we can leave that 1.24. Cost is monies per kilogram. You can actually set your local currency to help with this. Let's leave it at 20 monies per kilogram. Finally, you can add in a spool weight. Again, this is more for metrics. It doesn't really help for your end slicer settings, so we'll leave that at 0. What we're interested in here is our temperatures. Now for the nozzle, we have the ability to set a first layer temperature and then a layer temperature after that. So 210 is a great starting point and 205 for other layers. Same thing goes with the bed. We can set a higher first layer temperature and then followed by a cooler temperature for the following layers. Moving on to cooling, we have two fan settings. Keep the fan always on and enable auto cooling. I prefer to leave this setting on as it intelligently changes the fan rate based off your filament temperature and based off the speed of your printer. So if you're printing faster, it's going to cool more aggressively. If you're printing slower, it's going to slow down that fan. And the idea is to maintain a consistent cooling rate across your print. So let's leave both of these at default. Finally, we have filament overrides. Now the retraction settings here give you the ability to override what you set in your print settings, and we'll be looking at those shortly. So whenever you have an all-metal hot end, for instance, you may want to override this setting. This one comes in by default at 2 millimeters, so we're going to use 2 millimeters retraction because we have an all-metal hot end. If you have a Bowden tube, you might want to set this to 6.5, as that's the default Creality value. Usually 5 to 6.5 I find is good enough. But for the all-metal hot end, we're going to go with 2. Now the lift Z is similar to your Z-hop settings in other slicers, where you can define how high to lift the nozzle whenever you do a retraction. So if you get a lot of stringing and you can't overcome it, one way to get around some of the stringing is to have it lift the nozzle up so that the filament can seep downwards and create a little bit of a vertical cone rather than create stringing within your model. I personally like this setting, but some people don't like to have their Z-hopping around. So let's set that as a Z-hop of 0.2 millimeters. If we go and hit save, as mentioned before, this is a locked profile, so it goes to a default. So we're going to create generic PLA first layer. And we're all done with filament. Now the final tab at the top is your printer settings. This is your machine-specific settings that apply to regardless of what material or what print settings you put through. So let's take a quick look at the CR10S profile here. We can see under General, everything's hidden, and there are more advanced settings that we can expose here. So if you have a printer that has a different build volume, I always recommend starting off with one of the Creality profiles and changing your bed shape up here. So you can change your bed shape to be a 400 by 400 if you have a CR10S4, or you could change it to a 500 by 500 if you have a CR10S5. Now the only confusing thing here is that the bed shape field defines your X and Y. However, your max build height is also set over here. The Z offset is kind of a cool feature, and although it's a bit more of an advanced feature, it does allow you to program in a Z offset if you don't have a BL touch sensor, or if you're having a hard time with bed leveling where it's always consistently too close to the bed. You can set an artificial Z offset here and bump it up a few millimeters. Now since we have a BL touch and we know our bed is level, we're going to leave that at 0 for now. Let's go back to our simple view here and look at our first extruder. Now our first extruder is defined as a 0.4 millimeter nozzle, and you can see here the retraction for that is set to 6 millimeters by default out of the gate. Again, this was based off the Bowden tube. Now we went ahead and overwrote our length here under the filament settings for PLA. The problem with setting this here is that if you go to your PETG profile, it's going to go and start using your printer default, which is the 6 millimeters here. So we always want to set our setting for retraction globally for all filaments by setting it under the extruder 1. We're going to set this to 2 millimeters and 0.2 millimeters as per the other tab. If we go back to that tab, if we want to go and make these bind to the profile again, just click the lock and it'll go to NA, NA, and turn them off. Go ahead and save our first layer preset there again for the PLA, and back to our printer here. Now the extruder color, you can go, if you have multiple machines and you just accidentally forget to set it, you can go and set an actual extruder color here. So let's go ahead and pick a nice purple. And this one will match up with the color of the extruder. As it says here, it's only used in the Prusa Slicer as a visual help. Finally, we're going to have a look at dependencies here. And you'll see here there's really nothing we can deviate from this. So it looks like everything in here can't be modified. It's locked down. Our model is a CR10S. Default profile was set to the optimal creality and that. Now, if we were to go and try to reveal other features, it's not going to show anything. And this is the downside of using a default profile with this system, is it won't expose every single little setting. So there is a custom FFF printer profile that does expose everything. However, there are several overrides in there you have to be aware of. So I am currently working on a profile that I will upload to our Facebook group that gives you exposure to all the settings with some optimizations, but is optimized for the Creality machines. But for the sake of today's example, this is going to be perfect. So let's go ahead and save our print settings as Creality CR10S first layer and do OK. Okay, now that we've set all our settings, let's go back to the platter here, and we're going to go and take a look at our file. Now, as you've seen, we did go and modify the skirt and brim a few times, but it maintained the printer sliced files here. So we can actually go through and see that it's not going to regenerate that as mentioned before. Let's go ahead and hit slice now. So now we can see here, estimated printing time normal mode, 2 hours and 10 minutes. Now the information down in the bottom right is usually exposed in other areas on slicers and a bit clearer, but this is more valuable to your actual weights. So what we can see here is it's used about 4 meters of filament. The gram estimation for weight is 12 grams of filament, so a very small amount out of your 1 kilogram roll. Cost, based off our 20 monies per kilogram, says it's going to cost us 25 milli-monies. Let's call it milli-monies there. But it's basically 25 cents. So if you were trying to do print estimating for cost, this is going to tell you your material cost. We're not covering the actual cost of selling materials today. The 25 cents indicates the cost of material, not so much your time. So we're going to go ahead and hit export G-code, and it's going to go ahead and give us a nice long name. It looks like 3D Benchy with our profile information, and as a neat feature, it actually adds in its estimated runtime. So let's go ahead and save this, move it to our SD card, and give it a run on the printer. just like that, we got ourselves a benchy. Now this boat here took about 2 hours and 18 minutes to print, as per the screenshot you'll see here, and Prusa Slicer estimated that at 2 hours 11 minutes, so the estimation is actually quite accurate, which can be valuable if you are planning to schedule out all your prints back to back. Now the one feature we were talking about earlier was that Z seam placement. I want to show you that here on the benchy, and you'll see the roughest part of the print is actually right around that edge, and it looks like I've clearly got some work to dial in on my retraction and or my linear advance settings, but because all that roughness is located just down the center of the boat, it's going to be really easy for me to sand and clean up versus having to sand and fill holes all over the place on your model. But now I'd like to hear from you. Let me know in the comments below what slicer you use primarily, and if you've given Prusa Slicer a chance. I'd love to see comparison photos of your best profiles from each of your printers, and let us know what your experiences are. While you're down there, go ahead and subscribe and ring that notification bell to know when future episodes come out. And until next time, remember that the first layer is always your foundation to a great print.